Brought to you by thewoodshouter.com. Electronic Laser Pistol Target, Episode 1.
So down here we have ourselves. Alright. Function generator. Oscilloscope. It's a power supply. Nice power. No, that's a multimeter. That's our digital multimeter. That there is a cheap power supply. And a very fancy pants power supply here.
So my son was furloughed from his job as a substitute teacher in the San Diego City Schools District. He is trained in computer science engineering. Came out to visit in Illinois. I happen to have a lot of electronic equipment and electronic parts, Arduinos, things like that, transistors. So we decided to put our heads together and build an electronic target. This thing operates utilizing a laser bullet, and the parts were designed in Fusion 360 and printed on a 3D printer. And this is the project. Okay, Paul. So, how'd you spend your COVID vacation?
Did a lot of things, but one of the things I did was I built a project.
First of all, tell us why you had a COVID vacation.
Cause COVID. Okay, so the coronavirus shut down the schools. I'm a substitute teacher generally. I enjoy what I do, but the schools were shut down. I couldn't work, so I decided I would revisit some of my old learnings. I used to be a software developer. I studied computer engineering for a bit, and I was like, oh, maybe I'll do some coding for a bit with my time off. And so I found some microcontrollers. I went to visit my family. They had a bunch of electronics. My dad had a lot of electronics, so I decided to use some of his microcontrollers and build a little device that could be used for, I don't know, just a fun way to practice, I suppose, or something.
Fun way to practice what?
Fun way to practice. So the idea was, we had these microcontrollers, we had a lot of this electronic stuff laying around, and if you have a laser gun, effectively is what this is. If you have a laser, we made a target system for lasers, right? So some guns, you can get a bullet in them that allows it to fire a laser so you could practice fire it, right? So this gun, when you shoot it, will shoot a laser. And so what I decided to do was make something of a device or a game that you could use so that you could, practice firing indoors using one of these laser bullets.
Mm-hmm. So what you got there is a Glock 21. That's a 45 that's been converted with a magic bullet.
Yeah, there's a in the chamber.
So there's a laser bullet in the chamber that you don't need to actuate the slide in order to fire the gun. It automatically actuates the bullet each time you pull the trigger, which is kind of cool. And there's a store in San Diego, the Glock store, that actually developed those. They're not completely fail-safe. They kind of screw up every once in a while. They need a lot of adjustment, but I think I've got it working now. So yeah, it's as accurate as shooting a bullet. The only drawback is you don't get any feedback from the actual bullet going off. So you wanted to develop a electronic target where we could utilize that gun, right?
Yeah.
In the house and practice
trigger discipline,
Yeah,
right?
you don't have to buy ammunition or go to a shooting range. I mean, I know that was the point of the laser bullet itself, but and there are other targets in the market. But I decided to make a fun one that you could, you know, I could write a lot of code for and make different varying game options, and it's really open ended. There's a lot that can be done with this system. Right now, I have a box that controls 4 laser targets, but this one can probably host up to 8 laser targets. And you can just do a whole different assortment of things with these targets. And when you have a microcontroller, there's really no limit. Just how much time you're willing to invest and how creative you can get, I think, is the idea. Yeah, so it's a pretty fun little
So the
project.
targets you built, how'd you build the targets themselves, the plastic?
So we had a 3D printer. So the targets are made of PLA plastic. We designed them in Fusion 360, or we just used a CAD program to design the targets. We then printed. We went through a couple iterations. We were definitely prototyping a lot till we found ones that we thought were like a good size and had good responsiveness. So we have, I guess, our very first target that we printed is this plastic device. It's a little curved. It's nice. Didn't really have a place to host the sensor. When you put the sensor here, but didn't have a place to run the wires or anything like that. It was a little larger than necessary. Waste of plastic, and you're only really aiming for the sensor, the target itself. So this is just kind of overkill. So that was our first target that we designed. We later settled on a smaller version, so we got a smaller target here. This is what I think close to our final version was. This is after many iterations, and this is kind of what it looks like with the server, with the sensor inside of it. So it's a photoelectric resistor that measures light and changes the resistance of the resistor, and you use that in conjunction with another resistor to create a voltage divider that you can then use to get an analog input, right? So it's an analog input from a voltage divided photosensor, photoresistor.
And your processor in there, the Arduino, changes it to digital information, right?
Yeah, using an analog to digital converter. I've had some issues with the analog to digital converter, but for the most part it works. There's some things that are still a little, I need to tweak, but good enough for at least the application at hand.
And then what did you decide to use to actuate the target? These targets actually move, right?
Yeah. So this, each one of these targets has a servo in it. So this is just a basic 9G servo. We actually salvaged these from an old RC plane. So we took them from the control systems of the plane and decided to use them to actuate the target. So when you hit a target, it'll go down. When the target activates, it'll rise up. So this is what a servo generally looks like. I think this one might be a broken one. Oh no, this was good. So maybe we have broken 1 or 2 of these, but for the most part, they're good. Good enough for
9G servo. What does that mean? G is like the
I think
number
it's
of grams.
I'm not entirely sure.
Grams of force that
I haven't
it
looked it up.
produces.
We printed out a lot of different iterations of these bases. This is the base of the target. We've actually added to each of them 2 LEDs, a red and a green LED. We can turn these LEDs on and off to be used in the future games. We do have one game that we're working on that uses these LEDs, but as I was referring to with the errors in the analog to digital converter, these LEDs cause drops in the reference voltage that the analog to digital converter uses. And I had tried to use an external reference voltage. I don't know, I might have burnt out this particular Arduino, I'm not sure, but I was having trouble getting it to work. So that's future prototypes. This is version 1.0. Future ones, the LEDs will hopefully be functioning fine and not interfere with our sensor readings, because that's what we're having a problem with. The LEDs actuate, it changes the reference voltage, and then it causes false positives in the sensors when they are also red, right? But yeah, so you fit the servo inside the base like so, and it's pretty snug fit, secure. And that's what all 4 of these targets here have. They all have a servo. They've got 2 LEDs that can light independent of each other, so you can have a red or a green light or both light if you need or desire. And yeah, that's the basic target design, I think.
So I like your project box. What is that, a shoe box?
Yeah, it's just a shoe box. So just to keep everything kind of clean, keep it look presentable, we decided to use a shoebox as a project box. The basic controls, you have a power switch that activates a 5-volt power supply that's in here, just wall plug-in, right? So it just plugs into your normal wall. We've got a knob that's a potentiometer. I'm eventually going to swap that out with a continuous knob so you don't have to worry about being limited by the potentiometer. You can spin continuously in one direction or another. A simple button and an LCD that just displays the different menus and options that are going to be available here. So, yeah, I guess should I turn it on?
So here's the unit. So there's the actual target itself hooked to the servo inside the box, the 2 LEDs, and then the stand. And okay, yeah, let's flip the lid on the box and see all the
mess of wiring.
That mess of wiring you got inside of it.
All right, so here we go. This is the box here. Yeah. So popping this open.
Holy crap!
So we can see here we have our 5-volt power supply. It can supply up to 12 amps, which is overkill probably for this project, but we didn't want to have to worry about that. This breadboard controls all of the controls. So this takes the whole interface in. It's got the potentiometer, power supply. It does a few voltage dividers for the LCD, and it creates the button. It has the pull-up resistors for the button and everything like that. This breadboard just for all the control, just for these 2 targets, the left 2 targets, and this breadboard is for the right 2 targets, but it also has a Bluetooth chip that allows this to not only be controlled by the user interface at the top here. I've written a small iPhone app that allows you to control it wirelessly from your phone, so you can mess around with this using your phone instead of just the control.
Pretty cool.
Interface.
So you don't have to, you're not stuck to having to go to the box to turn on the application. You can turn it on from your iPhone.
Yeah.
That's pretty cool.
So it's pretty fun. I mean, and that's the microcontroller, of course, the Arduino, the brains of the operation.
Yeah, the Arduino's down there. That's a microprocessor, right?
Microprocessor.
Microcontroller.
That's right. Not a full-blown computer, no operating system, but.
So is that a 16-bit computer?
It's not a computer, right? Well, yeah, it is a computer. Yeah, 16-bit. No, I don't know. I don't even remember. Man, I should know that. Good question. I think you're right. It is 16.
I think 16-bit, isn't it? Is
32.
Is it 32?
I gotta Google. I don't. This operation doesn't require very large numbers, so I don't use much more than shorts. Like unsigned shorts hold plenty enough number. That's big enough numbers for me. I don't need anything more than that.
Well, fire it up. Let's try it out.
So powering it on.
Oh.
There it is, and we can see at the top here.
Lights are on the LCD.
Yeah, it's prompting it to select game mode. So right now we have 4 game modes. There's random targets, which is exactly what it sounds. What you do is you enter the number of targets you want to hit, and it'll randomly pop up targets. It'll time you how long it takes to hit those targets. So you can pick between 10 and 100 targets. I think I have it programmed for now. That could be changed. So if I selected 10, it would say hit 10 targets, and then it would time you and tell you how long it takes you to hit those 10 targets.
That's pretty cool.
Yeah, and then I have a timed trial. It's the opposite of that. Now you enter a time, and it'll give you 30 seconds to 5 minutes to hit any number of targets. It'll tell you how many targets you hit within that time period. So if you select a minute, it'll tell you how many targets you hit within that minute period.
And the targets are popping up randomly during that time, is that right?
Yes, the targets pop up randomly at that time.
Popping up randomly.
And then we have a dueling tree in which the first and last target appear. That's for if you have 2 of these guns, or if you have a laser pointers or whatever it is that you decide to use this for. You can compete with somebody in a kind of a similar fashion to what dueling trees are used in gun competitions, I believe, right?
So explain that a little bit. How does that work?
So the way it works is, 2 opponents go up against each other and they start firing at their prospective targets, and your goal is to lead your opponent by some number. So say you set the score for 5, you need to hit 5 more targets than your opponent. So you're both trying to get ahead of each other in the number of targets that you hit, and whoever can hit the most, whoever can get that lead wins. So it's not about how many targets you hit, it's how many targets you hit relative to your opponent. So 1 point for me is like 1 less point for you in a way. It's just
so it subtracts points from your
Essentially kind of subtracts points from your opponent's
In
score.
a way, yeah.
Kind of something like that.
Something like that. You keep track of who's hitting how many, and the real goal, it doesn't matter your total, it just matters your relative.
Right.
So
5 more. So you try to hit 5 more or 10 more or whatever you decide to set that number at.
Yeah, and right now I only have it running the first and last target,
Uh-huh.
but I'm planning on changing in future iterations so that instead of first and last target, it'll be the left so many targets and the right so many targets, right? Because like I said, right now I have 4 targets. This can host up to 8 targets. The code is good for that, at least, for the most part, except for like certain games. Like the random and the time trials totally works with 8 targets. This one, I just need to change it, because right now it just does the first and last target. But I could do the first 2 and the last 2, or the first 3 or first 4 and last 4. So you can have multiple targets that you're competing against each other with. And then the last game mode I have is this RG light. It's a red-green light. Basically, targets pop up sporadically. They have red. They're either red or green. If you shoot a green light, you gain a point. If they're red, you lose a point. And this is the game that I'm still futzing with because of, like I said, whenever an LED activates, it messes with the reference voltage that the analog to digital converter uses, and that causes false positives for these resistors. So we might show that for you, but you'll notice in that particular game mode, some of these targets are going down without being hit. And just want you to know that's the reason why. The reason the targets are going down without being hit is because an incorrect analog reading.
Reference voltage,
Yeah,
right?
yeah, the reference voltage the converter.
So I wonder if you isolate the LEDs and just use the output of the Arduino and then electrically isolate the LEDs. Would that help?
That would definitely be one of the solutions that we could use. So if we decided to run with some transistors to actuate the LEDs and then pull the current from the power
Voltage
supply.
source, yeah. Power supply.
Yeah, that would probably result in the reference voltage being pretty consistent within the Arduino, I would imagine, since you're not pulling current and causing drops in it. Another solution that supposedly should work is being able to use, there's an analog reference voltage pin that's on the Arduino that should allow you to use an external voltage as your reference voltage. But I just couldn't get it to work. I kind of had a limited amount of time to get to where I'm at right now in a way. But I will be working on it in the future, I think. Just need to... That's just something that I haven't quite gotten yet.
Excuse me.
Yeah.
All right, well, let's try this. Let's see how it works.
So let's go ahead and I guess we'll do the first game mode that I mentioned.
Why don't you turn it on or actuate it with the phone? Can you do that with the
I figured,
with the iPhone?
Yeah, I guess we could do that. So here, let me get the iPhone here. So I mean, you can do the same thing with that interface there where you scroll through it. Oh, this is on my iPhone. This is on our. It's funny. I actually don't have an iPhone.
Ooh, hit my head.
So here's I'm gonna open the app here. So it's this app right here. It's going to take a few seconds to load the menu because it every 15 seconds it broadcasts what the options are. So let's give it a few seconds here.
So it's talking to that Bluetooth chip that's sitting on one of those breadboards, huh? Inside the box.
So I have the Bluetooth chip. So there it is. It refreshed. So now it shows you the 4 game options: random targets, dueling tree, time trial, and RG light. The 4 I talked about. So I guess we could start with the very first one. So if I select random targets, it should... So now we're allowed to... I selected random, and now it's giving me options for the number of targets that we want to hit in increments of 10 from 10 to 100. So which should we start with, I think? 10 targets?
Go 10.
We'll just start with 10 targets. So it should tap here to continue. So once I push this button, the game will begin, and we will see the targets.
Okay, I'm going to try to shoot him. I'll be attempting to shoot here.
Oh. You really got to hit the sensors dead on in order to get them to... Close doesn't count here. This is not hand grenades.
Oops. See, I'm always going to the left there.
So edge shots don't work. So there it is. The beep signifies the beginning and the end of the game. And so we see that took him 27 seconds. 27 seconds to hit 10 targets.
Okay, let's
So-
try it one more time.
All
Let's see
right,
if
so
I'm warmed up now.
Once you finish, it gives you the option to play again, yes or no. So we're gonna play that game. All right, so let's go ahead. Random targets.
How many we're gonna go? 10.
Yeah, we'll do 10 again. So let's do 10. Tap to continue. So we're gonna on the beep. The game begins.
Boy, I'm really not. I think I need more light in here so I can see the targets better.
We should be able. We could turn up the light a little bit here.
My sights are dark.
All right, so that's the game. We'll see the score here. It took him 28 seconds, so a second longer than last time. So we can play again, or we can choose to go back to the main menu. So I'm going to say no. So back to the main menu, we can pick from the 4 options again. I'm going to go ahead and do a time trial. So this one, we'll see how many he can hit. We can pick 30 seconds up to 300 seconds, which is 5 minutes. How long you want to go?
30 seconds.
We'll go 30 seconds. So we'll see how many targets he can hit in 30 seconds. We saw that it took him 28 seconds to hit 10. So let's see if he beats that here. So I'm going to tap to continue. And it begins. All right, so he hit, it shows here the score afterwards. So 30 seconds has gone by. He hit 11 targets. That was the score.
Okay.
So averaging a little more than a target every 3 seconds, every
Okay.
2 point something seconds.
Restart it and see.
So he wants to restart it.
One more time. 30 seconds.
Yeah, all right, so play again. We'll push yes. The game's beginning. Well, actually, I have to pick 30 seconds again.
Yeah.
30 seconds again, so we'll pick 30 seconds. Here we go. All right, hey, big improvement. So he hit 13 targets this round, as opposed to 11. So it's definitely getting better. So we have the option to play again, yes or no. I think let's try a different game mode. All right, so we have. Well, let's try the dueling tree one. That's one that still
Dueling
works.
tree.
Dueling tree.
So I'm going to try to what?
So the goal here is it's normally a 2-player game. So I guess we can just show you that the first and last will go up. He can shoot left and right, and once he hits the number, well, I guess once he hits the right target more, we'll see that the.
Okay, wait. What? How many do I have to win by?
So we have between 5 and 50 we can choose. So
Let's
I think
go 5,
let's just go 5.
and I'll shoot the left target
Mhm. So
3
we see-
times, and then we'll have to hit the right target 8 times, right?
Yeah.
To win?
Yeah. So we saw that
There's
the
one.
both targets activated. Oh, that was a false positive. What is
3.
that?
Was that a false positive?
Looks like it, huh?
Let me give it 1. Okay, so we got to hit this one 8 times, right?
Yeah.
1, 2, shoot. 2, 3, 4, 5, 6, 7, 8.
And so that's the game. And we'll see. It says player 2 wins. Who's the right player? Right player wins.
That is really cool.
Yeah.
That's cool.
You want to play?
So I think the lights fluctuate. You might want to tell them what you did about ambient light.
Yeah, so every time a target reactivates, it determines what its ambient light is, and will take that into account and then check to see if the light that it's receiving is increased from the light that was set when it activated. So once the target's up, it says, what is my light around me? And then it saves that. And then if the light increases a certain amount, which I have coded, I could change that value as well as just how sensitive. I can change the sensitivity of the targets in code. I might make that something that you can change in a menu in the future iteration, so you can change target sensitivity depending on what kind of variation you're experiencing in your environment and how strong of a laser you're using. So the better the laser on your firearm, the less sensitive your targets will need to be, and the more variation you can have in your ambient light. We're in a pretty cool dimly lit place, but we could actually turn up the light a lot here and it should still work just fine because it's still only looking at relative change in light. So I'll show you, I'm going to go ahead and show you the red-green light, though just recognize that the scoring is going to be wrong because of the false positives that result from the inaccuracies in the reference voltage. So here's the red-green light. The way the game works is you pick a time limit, and so let's go ahead, we'll go 30 seconds. Well, yeah, we'll go 30 seconds, and you'll see the targets will pop up, and they'll be randomly popping up, and the light that they'll have with them will be red or green. So that'll be random as well. And the goal is green will give you positive points and red will give you negative points. So well, this time we're going to be using the green laser that's just kind of continuously on. So as we were saying earlier, the LEDs cause a problem with the analog to digital converter. So this next mode, it's going to be the RG light trial, and you'll see random targets going up and down, and as they go up they'll be assigned randomly to be red or green, and the goal is to hit as many green targets as possible and avoid the red targets. However, because these LEDs aren't controlled via a transistor, they pull current from the microcontroller, and when they pull current from the microcontroller it affects the analog to digital converter and will cause false positives on the targets. So you're going to see some of these targets going down very quickly when they should stay up for at least 6 to 10 seconds as the code goes. So the code shows that they should stay up 6 to 10 seconds unless shot, but some of them will go down almost instantly because they'll have a false positive. So just a heads up, it's not fully functional, but it's pretty close. So I'm going to turn on the interface here. We could scroll through to go to RG light and select it, or we could just, so it's a new game, right? We're gonna set it for 30 seconds, you think? 30 seconds. So actually we should see this app will give the options as well. So it should recognize what part of the menu it's in and properly show the correct menu. Let's see if that happens. Every 15 seconds it updates from the broadcast. There we go, 30 seconds. So 30-second game. So let me go ahead and sit down here. I'm going to press 30 seconds and we'll see the random targets. Yeah, 30 seconds. Continue. So they are, you see that they pop up with a random LED activated. Those are green LEDs. So you'll see some of them are instantly going down because they're getting a false positive. So once again, in the future edition, so it'll show the score here. It says 11 green and 9 red, but it's clear that he didn't hit any reds. It's just that 9 reds, red false positives because of the LEDs pulling current. So yeah, in the next, this is version 1.0. In version 2.0, we'll have transistors controlling the LEDs, and that should, yeah. So I'm pretty excited that all this worked that way.
Very nice.
Yeah, good times.
Till next time.
We're gonna be ace shooters by then. You know, you're gonna be hitting quarters 20 feet away consistently. You know, less than 3 seconds. No, good times though. All right, everybody. Hope you are all making the most of your COVID quarantine, and yeah,
And no rioting.
no rioting.